Good day. Today we're doing the 2022 May-June paper 23 extended. Let's get going. Question 1. All probabilities add up to 1 always. So finding not the probability of picking a red sweet is 1 minus 1.05, which of course is 0.95. Next question, let's substitute these values into the expression. So for m, we put 4, k is 7 cubed over square root 3. Don't waste your time, put it into calculator, which will be 4, 7 over root 3, and there we go, 792.124. rounded to 3 significant figures, 792. Question 3. Remember that all angles in a quadrilateral add up to 360 degrees. So to find angle PSR, we need to do 360 minus all the other angles in the quadrilateral. So let's do that. $83. So this will be this angle over here. Then of course to find angle PST, angles on a straight line is 180, subtract the 83 and we get the answer 97. Question 4, stem and leaf graph. Let's complete this. They've already put the first value in there, 0.3, there it is 0.3, 0.4 is the next one. Okay, remember this always needs to be in order. So first we're going to do on the side here, maybe in pencil, the unordered graph. So 1.2 will go in this row. So I'm going to put the T there for 1.2. 0.8, the 8 goes there. 1.1, the 1 goes there. 2.1, 1.7. After we've done that, now we can put it in the correct order. You'll see I go one by one. That reduces the risk of leaving any of it out. Right, so next one, 0.7 comes first, then 0.8. Always count them, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Yep, that's what we want, 12 partials. All right, find the median, which means the middle value. Doing this mathematically, we take the number of values there is, 12, add 1, and then divide it by 2. That will give us 13 divided by 2 is 6.5. That means the middle value is between 6 and 7. Not 6.5 is not the median. That is where our median lies. So if we go back here, this is the first, second, third, fourth, fifth, sixth. So 6.5 there. That's the middle. Okay, check again. There's 6 numbers smaller and 1, 2, 3, 4, 5, 6 numbers bigger. So the middle is between, what is that? 1.1 and 1.2. Halfway between those two, of course, will be 1.15. Question 5. The first 3 terms, remember n represents the position of the term. So to find the first term, we just put a 1 where the n is. So 1 squared minus 1 will give us 0. Term 2. We put a 2 where the n is. 2 squared minus 1. 4 minus 1 is 3. And term 3, of course, is 3 squared, which is 9, minus 1 is 8. There we go. Indices, rules of indices. Remember, when we divide, we need to subtract the indices. So 3 minus 5 is y to the power of minus 2. Okay. Of course, remember, you can write it as a denominator, positive denominator as well. So either one of those is correct. Anything to the power of 0 is 0. So x to the power of 0, not 0, it's 1. Sorry. Anything to the power of 0 is 1. So that means we got 7 times 1, which just gives us 7. Question 7 shows us a scatter graph. And there is 8 points plotted. Each of these crosses, these points, represents a day. So this is the day with the most visitors and the most money spent. Down here is the day with the least amount of visitors and the least amount of money spent. Okay. So for question A, one of the 8 days there is 410 visitors. So let's look at the horizontal axis because that's where the visitor is. Each there is 5 squares between 400 and 450, so each square represents 10, so 410 is there. So you're going to take your ruler and we go up from there, and that cross there represents the day 410 visitors were at the zoo. Going across from there, we can read the value of there. Again, there's 5 squares between the two values, so each square represents 2. So that over there will be 27. Okay, but be careful. $27 spent in a day doesn't sound right. That's why we need to look carefully what it says here. These are in thousands, so we need to add the zeros. 27,000. That sounds more like it. Okay, question B shows us the 9th day, right? And there's 175 visitors. So let's have a look. There's 160, 70, 175 will be over there. So we need to go up from there. And total amount spent was 9,000. 9,000 will be over there. So we need to look where this comes together. And that's where we need to draw our cross. Nice and big and accurate. Question C. Draw the line of best fit. Okay. Again, use a pencil for this. Green representing my pencil. Okay, so what do we not want to do? Let me show you what we don't want. Okay. We obviously don't want. We want the same amount of crosses above and below the line, but if you're going to do it, it's a bit ridiculous now. If you're going to do it like this, okay, look, I've got the same amount above and below, roughly 5 and 4, but obviously it is completely in the wrong direction. Okay, you don't want all the crosses above, or you don't want all the crosses below. These are all wrong examples. Okay, or very common is that we have the right amount above and below, but it's not spread evenly. Then you see all the ones that is above is at the top part and all the below ones is at the bottom part. So that's also wrong. Okay, so what you want to do roughly. Oh, the last mistake, very common mistake, starting at 0. Okay, you don't necessarily have to start at 0. Okay, see, that is also wrong. Okay, so what you do want to do, start somewhere close to the lowest value and end somewhere close to the highest value, and then try to get roughly the same amount of crosses above and below. Okay, these are very close together. Okay, so you get 1, 2, 3, 4 below, 1, 2 above, 3 on the line. Okay, I could drop it maybe a little bit lower. That's it. Okay, good. line of best fit. Part D, on the 10th day, the total amount spent is 22,000. So that's where we're going to start off. 22,000. We go to 22 on the vertical axis. That's 22,000. Now to see the number of visitors, we need to go across until we meet our line of best fit and then go down. Okay. So my value here will be 330. Looking at the mark scheme, because no two lines of best fit is exactly the same, they give you a range of numbers. Anything between 300 to 350 is correct. Well done. Question 8 says, without using a calculator. So, calculator. If we were to do this with a calculator, going 2/9 divided by 5/6, and we get 4/15. This is still 0 marks, even though we have the correct answer on the line. The reason is the big white gap I left blank there, because I'm not showing any working. Right, you need to show every step. So for dividing with fractions, we do the flip. So we swap the second fraction around. 5/6 becomes 6/5, and we multiply. Okay, from here you can do one or two things. Multiplying fractions is straightforward. You multiply the top with the top. 2 times 6 is 12. 9 times 5 is 45. Okay, and then we can simplify it by dividing the top and the bottom by 3, which gives us 4/15. Or you can simplify before you multiply. We divide the 6 by 3, that gives us 2. Divide the 9 by 3, that gives us 3. So when you multiply it out, 2 times 2 is 4. 3 times 5 is 15. You get the answer straight away. Either way, now that we've shown our working, okay, showing this step and then one of the other steps, then we get the answer, the mark for the final correct answer. Question 9, changing units. All right. Well, this units, that line means divide. So we can write 300 meters per minute as 300 meters per minute. So first thing I'm going to do, I'm going to change the meters to kilometers. So change meters to kilometers. Okay, what do? Kilo meaning 1,000. We need to divide it by 1,000. Okay, so we're going to do that. We divide this by 1,000. 300 divided by 1,000, of course, is 0.3. That will give us 0.3 kilometers per minute. Next thing is to change minutes to hours. Okay. So how do we change minutes to hours? 60 is the answer here. 60 minutes in an hour. So we want to change it to hours. We multiply by 60. So I'm going to change my answer from before, times it by 60. And there we go. 18 kilometers per hour. Question 10, a little Venn diagram question. Again, we just do it little by little, step by step. This n means the number of. Okay, they really give us the number of in each part of the Venn diagram, so that is pretty clear. Opposed to if there was words written in it, let's say it was names of people, Jack, John, Sarah, Ben, Alfred, then we have to add up all the names and then get the number of. Okay, but there is just the numbers already. Okay, so let's do this slowly. Let's start with A. There's an A. Let me indicate A. A is all of that. Then we got B. B is all of that. Then we think about that sign. What does that sign mean? The intersection sign. Okay, we got two signs. We got union and the intersection sign. Okay, union means in the one or the other or both. Intersection means in both. Okay, union, I also remember the word leave. Okay, if this was union, we would leave it like that, A and B. With intersection, we need to erase. Okay, and this means with intersection, with the end, the one we have, we need to only keep the part where they overlap, where they are in both. So I'm referring to this part here. Okay, that is the only relevant part. So we're going to erase everything else. So A intersect with B refers to that middle part only, where the two overlap. But, of course, yes, I haven't forgotten. There is something else. There is the complement. Complement, comma there, means exactly the opposite of what I've just got shaded. Okay, so the green part now is not what we want anymore. What we want is everything outside of that. Everything that is blue, let's get rid of the green stuff. That's it. That's what the complement indicated. So what is the number of in there? That's the 25, the 12, and the 3, which adds up to 40, of course. Well done. Question 11, we got a circle, we got lines in a circle, so obviously circle theorems. So we got those funny looking triangles, and the question states that which line is the diameter? So let's think of what circle theorems do we know that involves the diameter? And the one that springs to mind is this one. Angle in a semicircle. You see, the diameter subtended to the circumference forms a 90-degree angle. So what are we looking for here? We're looking for a 90-degree angle. Okay, so let's start here. In this triangle, GKH, we got 85 and 85, which will add up to 170. That means this angle here is 10. No 80-degree angles. So we can eliminate GK and H. GKH. It's not one of those, obviously. All right, let's look at this one. Triangle ABC. 6 degrees plus 94 is 100. So this angle here is 80. So there's no 90-degree angles here. So again, we can eliminate A, B, and C. Right, last triangle. Yes, as you know, it's going to be 8 plus 82 is 90. So that means this angle here is 90. Or rather, let's indicate it the right way, like this. All right, so which one is the diameter? Looking here, yeah, the 90 degrees was up there. That would be the diameter, meaning the line going from D to E. Doesn't look like it, but that is it. That's the diameter, form the 90 degrees. So DE is what we're looking for. Right, question 12 starts off by mentioning the common factor of 14 and 18. So let's say what is the common factors of 14 and 18. First, factors of 14, of course, is 1, 2, 7, and 14. Factors of 28, 1, 2, 4, 7, 14, and 28. So what we're looking at here, common factors, 1, 2, 7, and 14. So that's what we're looking at. Okay, let's write them down. So common factors 1, 2, 7, and 14. That's the first line sorted. m is a common multiple of 10 and 25. So let's write down multiples of 10. Let's start 10, 20, 30, 40, 50, etc. 25, 50. All right, as you know, multiples goes on for infinite amount of time, so we can have an infinite amount of multiples here. But of course, the first one there being 50, and then next one, of course, will be 100, etc. Spot the pattern. Okay, second line, sorted. Prime numbers, let's write them down. First prime number is 1. No, it's not 1, it's 2. Okay, don't ever say 1. 2 is the first prime number and the only even prime number. Then we go 3, 5, 7, 11. Again, goes on to one massive number. I don't know. People keep discovering the next biggest prime number. Okay, work out the largest possible value of f over mp. So let's see. We need to think very carefully here. Okay, largest number. So for f, we want to take the largest number. What is the largest number we have? There it is, 14. So we're going to put 14 over. Now think carefully. When we divide 14 by a number, we want to divide it by the smallest possible number to get the biggest possible answer. Okay. Does it make sense? So for example, if we divide 14 by 7, we get 2. But if we divide 14 by anything smaller than 7, let's say 3, we get something bigger. So the smaller the bottom part is, the better. So for these two values, we want to pick the smallest possible values. So what is m? M is a common multiple. The smallest one we have there is 50. So for m, we're going to take 50. And the prime number, the smallest possible one we have there is 2. So that will give us 14 divided by 100, which of course is 0.14. Okay. Now, very important. In the mark scheme, it says not from wrong working, which means you need to clearly show how you got the answer. All right. So, well, this is 3 marks and then the right one. Very important. Question 13, factorising. Right, so let's break down these numbers into their factors. 18 we can break down into 2 times 9 times b times x. 27 we can break down in 3 times 9 times b. So the common factors there is, of course, 9 and p. Okay, we need to find them all because it's completely, find all the common factors. So that will give us 9p in front of the bracket. Inside the bracket, we've got left 2 and x. And over there, minus 3. And we've done it. Well done. For part B, I think it would be wise to rearrange this expression. And there's more than one way we can rearrange it. But what I'm going to do is put the terms with the m together. So m and minus m. Remember that minus goes with the m. So if we rearrange this expression, it will be mt minus m. Okay. And then I'm going to leave the nt next. And then with that, I'm going to put the minus n. That minus of the n needs to move with the n. All right. So now we can factorize these separately. So for the first part here, we can factorize out the m. So we're left with m bracket t, and look here, minus 1. Check, yeah, because if we multiply m to t, we get mt multiply m times minus 1 gives us minus 1m or minus m. That's very important. On the second part there, we can factorize out the n. So we got plus n. We're left with the t, and again minus 1. Because when we multiply it out, n times t is nt. N times minus 1 is minus n. Beautiful. It's looking good. Next step would be to factorize out this whole bracket, t minus 1. So we can do that, t minus 1. And in the next bracket, we put what is left, the m and the n. And bam, we've done it. Okay, that is how we do this factorization. It does require a little bit of practice. Question 14, some fun with sequences. The first thing we do with a sequence is we look at the term-to-term rule. How do we get from the one term to the next? So here we add, first we add 9. 8 plus 9 is 17. 17 plus 15 is 32. 32 plus 21. And then we add, what's that, 27. Alright, so the second difference is the same. We're adding 6 more each time. And when we see that, we know we're dealing here with a quadratic equation. Quadratic, of course, means n square, square numbers. So what is the square numbers? Let's see. Basic quadratic square number sequence, of course, is 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9. What's going 4 times 4 is 16. Okay, so what are we adding here? Yeah, let's add 3, add 5, add 7. So the second difference here is 2 more each time. Okay. We can then do the next one when we double that. So we take the quadratic sequence and we do 2n squared. So that would be quadratic square sequence, but 12. Yeah, 1 becomes, but double. 1 becomes 2, 4 becomes 8, 9 becomes 18, 16 becomes 32. Just double the square numbers. So now we're adding 6, then we're adding 10, then we're adding 14. So you see, we're adding 4 more each. You start spotting the pattern. Okay, yes, so the next one is what we were looking for. Okay, if we do, I'm going to do it over here, 3n squared. So it's the square numbers but tripled. So 1 becomes 3. 4 becomes 12. 9 becomes 27. 16 becomes 48. So what are we adding now? We're adding 9. We're adding 15. We're adding 21, which is 6 more each time. So now you can see we spot the pattern we had at above. So we know we got the 3n squared sequence. Okay, but again, it's not exactly the same. Okay, the sequence they gave us starts with 8, then it's 17, then it's 32, then it's 53, where R starts with 3, yeah, which is 5 less. And if we subtract 5 each time, 17 minus 5 is 12, 32 minus 5 is 27, 53 minus 5. That is clear. That is the quadratic sequence, square numbers, tripled, but with 5 subtracted. And then you got the answer. Question 15, solve. Okay, straightforward. I'm going to do it the way easy, straightforward way. And then there's another way, but where a mistake can sneak in. So we solve this like any other sequence. We subtract 4x from both sides, or we subtract the 4x from the left. And we got the 13 on the right, and then we're gonna add 3 to both sides, so add 3 to the other side. Okay, so that will give us 8x is 16, and then we divide it by 8 both sides. X is bigger or equal to 2. Okay, they didn't ask us to write the actual possible values. Yeah, that would have been 2, 3, 4, 5, up to infinity. Oh, goodness. All right, but be careful here. There's something else that could happen. Right, if we were to do this the other way around. Okay, let's say I move things the other way. Let's write this down. If I were to work the other way around, so meaning I subtract 13 here and I subtract the 12x there, that will give me minus 16 and minus 8x. Next step will be to divide the minus 8. Two negatives makes it positive. All right, you see what's happened here? We got a different answer. On the left, x is bigger or equal to 2. On the right, x is smaller. It's a different answer. I did everything correct, but I got the sign wrong. Okay, this is why when we work with inequalities, it's very important. The moment we divide with a negative, the moment I divided that minus 8 over there, okay, we need to swap the same sign around to make sure we get the right answer. So be very careful if you ever do this the other way. You see now the x is bigger on the bigger side or equal to 2. We got the same answer. These two answers being the same. Okay, be aware of that. Be careful. Question 16 is a speed time graph, and they basically want to see if you don't get confused with a distance time graph. Okay, now a distance time graph goes when we are going up. It means we are going at a constant speed, whereas this one, that's an acceleration. Distance time speed graph is a horizontal line. You don't move at all, you're stationary, where this is a constant speed of 10 miles per second, shows us there. And this is of course a deceleration. With distance time, it means you are moving back towards the original starting point. But either way you want it, D is just plain ridiculous. I've never seen that, so that cannot be correct. So the first one is D. Constant speed then is B, where we're going at a constant 10 meters per second. And acceleration is where the speed is increasing from 0 meters per second to 10 meters per second. So A would be the acceleration. No, not. We're not accelerating. We're decelerating. My goodness. Okay. Going slower. We're decelerating from 10 meters per second to 6 meters per second. Deceleration. Okay. Don't make my mistake. Read the question carefully. Acceleration is A. Deceleration is C. Now we go right. Okay, now we get back. The acceleration, going faster, okay, in a speed time graph is the gradient. Okay, remember the gradient is the change in y over the change in x. So looking at the acceleration there, we can draw a right angle triangle. The distance over here is 10 and there is 13. So the gradient here will be 10 over 30. Simplified is 1/3. Okay, or 0.3 recurring. Last one, the distance traveled in the first 30 seconds of the journey. Okay, and that will be the area under the graph. So just the first 30 seconds, we got a triangle there. Area of a triangle is half base times height, which will be half of 300, gives us 150 meters. Now we got it. Question 17, all about congruence, and they made it easy this time. We just need to fill in the gaps. All right. So congruence means exactly the same. Two triangles that are exactly the same. The rules of congruence, remember, is we need to have all the sides the same length. We need to have an angle and two sides or we need to have the side and then an angle and a side, or a right angle, a hypotenuse and the side. Is that it? If I'm wrong, let me know in the comment section. Okay, so let's see what they say. AD, so let's mark what they say. AD is perpendicular to BC. See that? That means angle, let's do that, angle ADC, which is marked. So this is the obvious. They just want us to state the obvious. Angle ADC or CDA, but keep it alphabetically, is equal to the angle on the other side, that one there, which is ADB or BDA, and they are both 90 degrees. Okay, so this shows us the two angles are the same, but this is a right angle. Okay, so we got those two the same. Okay, next one, AC equals AB. So given that to us, they told us they are the same. Don't even have to do that. That and that is the same. All right, next point. Side, which side is common in both triangles? That's the one down the middle. It's the side both of them has. This one here, see, common in both. So that will be side AD. So what we got? We got the right angle. We got the two sides, AC and AB, okay, which is also, of course, not just a side, it's the hypotenuse of those right angle triangles. And then we got another side. So the criteria is right angle, hypotenuse, side. Okay, congruence requires a bit of studying. Make sure you know the requirements. Okay, it's one of the topics students neglect in studying, and they've been asking it a lot more lately in the exams. Question 18, calculated. Right, the bearing of B from A is X. We can see that. The bearing of A from B is Y. We can see that. And then they give us the ratio. XY is 2 to 7. Okay, now that's all straightforward. One thing to never forget when we are doing bearings is we're also working with these ones, parallel lines. So all the rules that apply to parallel lines we can look out for. The F or corresponding angles, the alternate angles, and the co-interior angles, which is 180 degrees. Okay, that means that if I want this angle over here, these are co-interior angles of two parallel lines, and they add up always to 180. So I can write that this angle over here is going to be 180 minus X. That is awesome, very helpful, because now what do we have? We've got angles around the point. So we now know that angle Y plus the other angle, which is 180 minus X, equals 360. Let's do some rearrangement there. Subtract the 180 there, so Y minus X equals 180. Sweet! So what other information do we have? This ratio. Okay, X to Y is 7 to 2. So the 7 is the Y, the X is the 2. So let's put that ratio in here. So if Y was 7 degrees and X was 2 degrees, that will give us a difference of 5 degrees. But it's not. The difference is not 5 degrees. It's 180. So how do I get from 5 to 180? Well, let's just do the opposite. 180 divided by 5, 36. So my ratio is 36 times too small. And that's what we need to do with our values then. We need to multiply it by 36. Let's do that. So 36 times 7, 252. 2 times 36, of course, 72. Does that equal to 180? Bam, it does. So there we got it. Y is 252, X is 72. Okay. Is it right? Yes, because if we do that as a ratio, let's put it as 72 over 252, it will simplify to the ratio 2 to 7, as was given to us there, 2 to 7. So we got it. Y is 252. They only want to know Y. That's the only one. Yep, I only wanted to know Y. Question 19, fun with functions. Here we go. Fine. So let's write down what we got. It's talking about the function f. The function f is kx squared. But what they've done is they've changed the x for minus 5k. So we need to change that x for minus 5k. So instead of writing x, we're going to write minus 5k. Okay, that's a bit ugly, so I'm just going to do that again. So it is k minus 5k squared instead of x squared. And they gave us the answer 675. Right, so let's do this. Everything inside that bracket needs to be squared. The negative 5 needs to be squared, right? So remember, negative 5 in brackets, very important, in brackets, squared, of course. 2 negatives makes a positive, that will be 25. So this is k times 25, and then we just square the k as well, because it's inside the bracket, so that will be k squared. Then we need to multiply it with the k in front, so k times k is k cubed, so that will give us 25k cubed. Next step would be to divide the 25 over there, so that gives us k cubed equals 675 divided by 25. 27, which starts to look not too bad. And then we cube root, of course, cube root of 27. Hopefully remember that is 9, because 3 times 3 times 3. No, it's not 9. It's not 9, of course it's not 9. Because 9 times 9 is 81 times 9 is one massive number, is 3. Okay, 3 times 3 times 3 is 27. Okay, don't make silly mistakes in the exam. If you end up, use your calculator. Question 19b. First, we need to write down the function of g, which is 1 over x. Then in there, we need to put the function of h. So instead of x, we put h. So that's 1 over 7x minus 2 over 5. Okay, so it's like a fraction over a fraction. We can write this in a linear form. So we can write this as 1 divided by 7x minus 2 over 5. Okay, or rather, let's make that 1 over 1. So we got two fractions. Nice, see, now it's a simple fraction. Questions. Remember, with fractions, we invert and multiply. So we swap that fraction to 5 over 7x minus 2, and we can multiply. Now, isn't that straightforward? 1 times 5 is 5. 1 times 7x minus 2 is 7x minus 2. And we've done it. Question C, let's first do the inverse of h. So let's take that function of h, set it equal to y. So that means y equals 7x minus 2 divided by 5. And then we rearrange to make x the subject. So we multiply the 5, that will give us 5y equals 7x minus 2. Add the 2 to the other side. And then we divide the 7. So that will be 5y plus 2 divided by 7 equals x. So our final answer here would be the inverse function of h. Now when we write this, remember to change that y back to an x. 5x plus 2 over 7. Now we can take the inverse function, which we just calculated, 5x plus 2 over 7, and add to that the function of j. What's that one? There. 3 minus 10x over 14. So our first step here would be to get the denominators the same. And here is pretty straightforward. To get both as a denominator as 14, we simply have to multiply this by 2, which means we need to multiply everything at the top by 2 as well. That will give us a common denominator of 14. So that will be 2 times 5x is 10x, and 2 times 2 is 4. Then we got the plus 3 minus 10x. Next step will be to simplify it. And beautiful, 10x minus 10x is 0. 4 plus 3 is 7. Simplest form means we just simplify it, divide the top and the bottom by 7. Sure you spotted by now. Final answer is a half. Brilliant. You're a genius. Question 20 is a challenge, but we take it step by step and we can solve this. The diagram shows a square ABCD. So what do we know about a square? All the sides are the same. So that is K, this is K, this is K, this is K. MDE is a sector of the circle, of a circle, center D. We can see that. So remember now, this is the radius of that circle. If that's the center, the radius and the radius. E lies on the diagonal. Okay, that must be important in some way or they won't emphasize it. So remember that E lies on the diagonal of the square. M is the midpoint of AD. So we can now change what we know here. If AD is K, this part here will be half of K. And that will be the other half, which means the radius of our circle is half K. Okay, or K divided by 2. See, now I have dealt with every piece of information and see what I could find from it. If I couldn't straight away get anything from it, I highlighted to get back to it. So that diagonal, we'll get back to that. Find the percentage of the square that is shaded. Right, so that sounds crazy. There's no numbers. Okay, but working out a percentage, we need to take the total amount. So I get to talk about the area. So let's start with the area of the square. That will be easy. That will be length times width, which is K times K, K square. Okay. Then we need to find the part that's not shaded. So let's work out the area of this sector. Okay, what is that? How do we work out the area of a sector? Remember, it is, let's write it down, area sector. Now a sector is just part of a circle. The formula for the area of a circle, of course, is pi r squared. But that sector is a fraction of the circle, so we need to work out what fraction it is. Okay, and what we need here is the angle of 360. So we need this angle here. How could we find that angle? What piece of information is there that we haven't used yet? The diagonal. What does that mean? Diagonal of a square. What does the diagonal of a square do? It cuts the corners in half. So this is 45 degrees. Smart. See, I knew we were going to have to use that somehow. Every piece of information is important. So what else do we know in this equation? Well, we know the radius is half a k. So pi times half a k squared times 45 over 360. So how can we simplify this? Because we're not going to get the answer. We're going to simplify it. So, well, we can write it as pi times k squared over 2 squared. To simplify that, 45 over 360 is 1/8. And then we can multiply together all the numbers. So that 2 squared, of course, is 4. So what's 1/8 times 4 times a quarter? You know what it is. You don't need a calculator. It's 1 over 32. Okay, so it's 1 over 32 times pi times k squared. Okay, we can squeeze it all together. Okay, remember this is over 1, that's over 1, so we multiply the top. So the best way to write this is pi k squared over 32. Okay, let's simplify it there. That's what we got. Okay, what do we need to do? We need to work out a percentage. So let's change this to percentage. Percentage is the amount we have out of the total times 100. So what do we have? We got this is the area of the sector. So if we do pi k squared over 32 divided by the total area and then times 100, we'll get the percentage that is there, that is not shaded, that sector of the whole thing. So how are we going to handle this? Let's write it next to each other. So pi k squared over 32 divided, is that what that big line means, by k squared, and we can put it over 1 and then we times it by 100. Okay, so again, this is the third time in this paper I think this has arisen. When we divide with fractions, we invert, we swap that around, and we multiply. Now this is just plain awesome, because now that k squared divided by that k squared will cancel out. So what we're left with is pi divided by 32 times 100. And that we can work out. Let's do it. Pi over 32 times 100. Bam. Got an answer. 9.817 etc. So what is that? That is the area, percentage area of the sector. Is that what they want? They want the percentage that is shaded. So they don't want this, they want this part. So how do we do that? Well, the whole thing, of course, is 100%. So to work out the last bit, we just need to do 100% minus what we just done. So on my calculator, I can just do 100 minus my previous answer equals, and it's just over 90%. Okay, rounded to 3 significant figures is 90.2. And what did I tell you? I told you we can do it. Well done. Question 21. We're talking about Neha's ribbon. And the moment you see these words, correct to the nearest, we know that that number, that 23, is not the exact value. It has been rounded. Okay, it's been rounded to the nearest 1 centimeter. So what you immediately need to do is you take that 1 centimeter and you divide it by 2, which will give you half a centimeter. So when you take the 23 centimeters, you need to first subtract. This is half a centimeter, which will give you 22.5 centimeters. That is the lower bound. That is the shortest possible length for the ribbon. And then you take the upper bound, you add a half, that's 23.5 centimeters. Okay. We need to do the same with the next one because that's been rounded to the nearest 1 millimeter. So 1 millimeter divided by 2 gives us half a millimeter. Okay, so we take the 87, lower bound, subtract half a millimeter, that will be 86.5 millimeter, and the upper bound will be 87.5 millimeter. Okay, now she's cut off a piece and we need to find the upper and the lower bound to mean the longest and the shortest possible length of the remaining ribbon. First we need to get our units the same. Okay, they want the answer in centimeters, so we need to change everything to centimeters. Remember, change to centimeters, millimeters, centimeters, we divide by 10. So 86.5 millimeters is 8.65 centimeters, and the upper bound is 8.75 centimeters, which makes sense because that's what she cut off. Okay, so cutting a piece off means we need to subtract. And after subtracting, we need to get the biggest and the smallest possible answers. How are we going to do that? Get the biggest and the smallest possible answers, right? And this is a bit more complicated. We have to think carefully. You know what I'm going to do? I'm going to do every single calculation and then we'll see what happens, okay? So first of all, let's take the smallest value subtracted by the smallest value. Next, we'll take the smallest value subtracted by the biggest value. Then we'll take the biggest value here subtracted by the smallest. And lastly, the biggest is subtracted by the biggest. So now we can clearly see what is our smallest value there. And this is this one. That's the smallest. Okay, the one where we took the lower bound subtracted by the upper bound. So when we subtract with bounds and division as well, it is a bit more complicated. It is not straightforward lower bound and lower bound. Okay, it's the other way around. So for the lower bound is 13.75, which makes sense. If we take our shortest possible length for the one and subtract from it the longest possible length for the other one, we will get the smallest possible answer. Same goes for our biggest value, which is here. Okay, where we subtracted from the upper bound the lower bound. So we took the smallest possible length of the ribbon and we cut off the biggest. Now we took the biggest possible length for the ribbon and cut off the smallest possible length, will give us the biggest possible answer. Now this is just one way of doing it. If you can remember to think carefully, you just need to do those two middle calculations. You don't need to do all of them to get the right answer. Okay, and always make sure your fives look like a 5. We've done it. Question 22. Some more fun with factorization first. So let's factorize what we got above the line. Common factor there for both is an x. So that will be x 5 minus x. Remember, when we multiply it out, 5 times x is 5x. X times minus x squared. Below the line, we got a complete square, right? We got a square number, square number and a minus in the middle. So that's a special case where we can factorize it. Quadratic, of course, two brackets always. Square root 25 is 5. Square root x squared is x. And we put a plus and a minus. Okay. For those of you who've forgotten about this, right, when we multiply out those brackets, 5 plus x, 5 minus x, it will look like this, of course. 5 times 5 is 25. 5 times minus x is minus 5x. X times 5 is plus 5x. And x times minus x is minus x squared. 25 stay the way it is. Those two middle terms will cancel each other out. And minus x squared, we're back where we started. So that's why we can do this. Okay. What we got now, we got two brackets that's the same. 5 minus x can cancel with 5 minus x. And we're left with x over 5 plus x. That bracket being optional. Don't cancel those x's. There's a plus there. Can't cancel them. It's your final answer. Easy, 3 marks. Well done. Question 23. Let's start solving this equation like we would do with any equation. We'll start with 3 sin x plus 3 equals 1. First, we'll subtract the 3. So that will give us 3 sin x equals negative 2. Then we divide that 3. So it's sin x equals minus 2/3. Next comes the sin. So we do the inverse of sin. Sin to the power of minus 1. Negative 2 over 3. And we hammer that into our calculator. So we got shift, sin. That negative you can put it in front, above, below, it doesn't matter. All give the same. And we get an answer. Minus 41.810. Okay, at least 5 significant figures. Right, is that our answer? Damn it, no, it's not, because it's not between 0 and 360. It is smaller than 0. It's negative. All right, this is where we need to remember what the sin graph looks like. So there's the sin graph. And if you remember, we've just done, we had sin x equals negative 2/3, which will be over here somewhere. So that will be negative 2/3. Now, if we continue our graph this way, negative 2/3, that will give us the negative over here, minus 41 degrees roughly that we were looking at. Okay, so we're off the graph. But if we do continue on the other side, you'll see we cross our graph in two places between 0 and 360. Where is those two places? Roughly is somewhere around here and somewhere around there. Okay. Close to halfway between 180 and 270. Okay, wonderful thing about this graph, it's symmetrical. So it means that this distance, which is roughly, remember, 41 degrees, it means this distance here is roughly 41 degrees, and this distance here is roughly 41 degrees. So to get our answer, we simply have to add to 180 and subtract from 360. So going back here, first thing we're going to do, we're going to do 180 plus what we just got there, which will give us, still have it there, just need to make it positive. So I'm going to multiply by negative 1 and then add it to 180. And there we go, 221.81, etc. That's our one answer. We can write it in. Round it to 1 decimal place. This is very important, right? It says in Cambridge, angles, you write to 1 decimal place. So do not write 222. It's going to cost you a mark. angles is rounded to 1 decimal place. Right, the other angle was 360 minus what we had there. So let's do 360 minus 41.810. Okay, and that gives us 318.19 rounded 318.2. 1 decimal place. Full marks. Once again, you genius. Question 24. Let's start by putting that sentence, the first sentence, into a mathematical language. So it tells us y is proportionate inversely, which means we put it as a denominator, to the cube of x minus 1, not the cube root. Read that part very carefully, because lots of students make mistakes. They write square, or they write square root, or they write cube root, just cube. Okay, when we bring in the equal, we bring in the constant ratio. Okay, now we need to work out what is that k. So we substitute the values they've given us into our equation. So y is 9.45 and x is 3. 3 minus 1 being 2. 2 cubed is 8. So to find k, we just multiply that on the other side. So we have 9.45 times 8. 75.6. So here we go. We now take our equation, we write it again, but with the value k. 75.6 over x minus 1 cubed. So now, to find y when x is 4, we substitute 4 into our equation. So that will give us y equals 75.6 over 4 minus 1 cubed. Don't waste any time. Grab your calculator, hammer it in just like it is. Don't even think. Just put in your calculator. I mean, do think, but not too much. And then you have the answer, 2.8. Well done. Question 25. Indices. Let's do this. Let's remind ourselves of the rules of indices. Okay. First one, if we are multiplying with indices, we add. Now the base number, of course, needs to be the same. So that will be a plus b. If we are dividing, we need to subtract the indices. If we have a power to a power, like that, remember, we multiply them together. If we have a negative index, we can write it as a fraction, as a denominator, and it becomes positive. What's the other one? Oh, the fractional indices is the same as a root. Okay, study these things because you need them. So let's use some of those rules to see if we can manipulate what we have over here. Okay, so first of all, I'm going to get rid of those negatives. So m to the power of minus a quarter, we can write as m1 over m to the power of a quarter. Same with the next one. We can keep the 27 above the line, and that m moves below the line. M to the power of 1, you don't have to put the 1, but you get the idea. It becomes positive. Sweet. So this looks good now, because now I can move all the m's to the left, because we want to solve m, we want all the m's on the left. We just want. Okay, so all I need to do is I need to multiply this on the other side, so meaning it goes to the top. So it looks like this. Okay, I'm making this up as we go along, but this is what you need to do in the exam. Right, we got division now. All right, so we've used this rule. I'm going to use this rule now. So I'm just going to rewrite this thing on the left. So it's m to the power of 1, remember, or just m, divided by m a quarter equals 27. Okay, so what do we have there? We're dividing, so we need to subtract. So that would be 1 minus a quarter. What's 1 minus a quarter? You know that. That's 3/4. So it's m to the power of 3/4. Okay. So, well, what do we have? We can now use the fractional rule. Okay, and rewrite that 4 as a root 4. So the denominator 4 is the same as root 4. Okay, don't forget there's a 3 as a numerator at the top, and that's just like a normal 3. That's like a cube. All right, things starts looking good. This is solvable. Because now, to get rid of the cube, we need to cube root. Cube root everything, cube root the other side. So we're left with root 4 and cube root of 27, which of course is 3. Not 9, like I said the other day. 3 times 3 times 3 is 27, root 3, 27. Got it. Good. Next thing to do, get rid of the root 4, and that means we need to set everything to the power of 4. So m equals 3 to the power of 4. So 3 times 3 times 3, 27 times 3. If you're not sure, put it in your calculator. 81 it is. And that's what the mark scheme says. So I'm very happy because we got it right. Make sure you know your index laws, play around with them, and before you know it, you got that A star. You genius. Well done. That's it. I hope you had as much fun as I did. Please like, subscribe, comment, let me know what you think. See you again soon. Adios.